In this video, we're going to go over test 4. So our first question is angular momentum. And if you remember, angular momentum is L. And so for P, L equals 1. So next question, what orbital is that? So that is d orbital. Our little cloverleaf there is always a d orbital. Select all the impossible orbitals. So we have to remember our rules for this. N1 goes to infinity. That's the possible levels of n. L is anywhere from 0 to whatever n is minus 1. And m's of L is negative L to positive L, including 0. So our first one, n and L are the same. This breaks the rule of L, so not possible. Here, n is 0, breaks the rule of n, not possible. This is possible, breaks no rules. This is possible, breaks no rules. Here, n is negative, n cannot go below 1, so impossible. So next one, how many electrons can be in the second principal energy level? So we have the 2s orbital, the 2p orbital, 2s2, 2p6. 2 plus 6 is 8. What jump between energy levels would need the shortest wavelength of light? The shorter the wavelength of light, the higher the energy is. So if we remember from our diagram in class, the higher you go up, the closer the energy levels are until they just start stacking on top of each other. So 1 to 2 is the biggest jump. So the lower the numbers are, the bigger the jump. The bigger the jump, the more energy you need. The more energy you need, the shorter the wavelength. So that'll be 1 to 2. What is the electron configuration of calcium? This one you need the periodic table for. So not much to explain there. Same thing for TC. What is the energy of interaction between a cation with charge of 2 and anion with charge of 1? So if it's an anion, that means it's negative. So it's minus 1. They're separated by 1.25 meters. So Q1 multiplied by Q2 divided by R. So 2 times negative 1 divided by 1.25 is negative 1.6. So how many valence electrons does P have? So P has the electron configuration of neon, 3s2, 3p3, 2 plus 3 is 5. How many valence electrons does Y have? So Y has the electron configuration of krypton. Then it's 1, 2, 3, 4, 5s2, 4d1. 5 is the highest energy level. There's 2 there, so that's why it's 2. What's the effective nuclear charge of valence electrons of lithium? So lithium has the electron configuration 1s2, 2s1. So 2 core electrons, 1 valence electron, 3 protons. So it's number of protons minus core electrons for an effective nuclear charge of 1. What is the electron configuration of chromium 2 plus? So let's do chromium. Chromium, where are you? There you are. Chromium is argon. 4s2, 3d4. If I'm plus 2, I'm losing 2 electrons. I lose them for my highest energy level. That's why it's 3d4. Carbon minus 2. So carbon is helium. 2s2, 2p2. If I'm minus 2, I gain 2 electrons. That's why it is a 4. Okay, choose the orbital diagram that shows N. So N is helium, or let's do the full thing. 1s2, 2s2, 2p3. So that's telling you how many electrons should go in each square. And if you remember our rules, you want to have electrons be by themselves instead of paired up if possible. So that's why the first one is the correct answer. All right. So which has the largest radius for any particular atom? That's always the negative atom, so the anion. Which elements show decrease? So when you become more positive, you get smaller. And the only case you're becoming more positive is N3 minus going to N. Every other case, you're becoming negative, so you're getting bigger. Select the true statement. We talked about this for lithium, but core electrons shield outer electrons. Which period 3 element has a large ionization energy? So the jump happens between ionization energy 6 and 7. So we're looking for something with 6 valence electrons because that jump only happens when you're trying to remove core electrons. And so our configuration here is neon 3s2 1, 2, 3, 4, 2p 3p4. So has 6 valence electrons. Then when I try to remove the 7th, that's a core electron. There we see our jump, and that is why sulfur is the correct answer. Okay. Place the following in order of increasing ionization energy. Ionization energy is biggest in the top right of the periodic table. So fluorine is your biggest. And so this is just asking you to order from bottom left to top right. And that would be AS and then F. Metallic characteristic. Francium, bottom left, is the most metallic. So it's just asking you to go from top right to bottom left. So here we're just going down the same column. So sodium, potassium, rubidium, cesium would be correct. What's the Lewis symbol for N? N has 5 electrons. So we have to pick the one with 5 electrons. Br minus has 8 electrons. So we pick the one for 8 electrons. Chemical compound for Al and O. Al has 3 electrons. O has 6. I'm going to try and get rid of my electrons in Al and try to get 8 for oxygen. So I do that. That oxygen's good. Aluminum has 1 more. So give that away. That oxygen's good, but we need, well, that aluminum's good rather. That oxygen isn't. So now that oxygen is good, but aluminum still has 2. I need to get rid of those. So bring in another oxygen. Now everything's good. That's Al2O3. Place the following in decreasing magnitude of lattice energy. So remember, for lattice energy, something, well, first let's just look at our ions, right? So we're doing anions are F, I, Cl. They're all -1 charge. Our positive are NaCs and K, all +1. So all the anions are -1, all the metals are +1. So usually for this, the more negative or positive you are, the bigger the lattice energy. We're dealing with the same charges. So we have to go on size now. So the smaller you are, the bigger the lattice energy. So our smallest combination is NaF, followed by KCl, then CSI. So the smaller you are, the more negative your lattice energy. So that's the correct answer there. All right, number of valence electrons in Xeon Cl4. So Xeon, I'm just going to draw out the Lewis symbol. Xeon has a full octet, so that has 8. Cl had 7, and we have 4 of those. So 7 times 4 is 7, 14, 21, 28. 28 plus 8 from Xeon is 36. So that's why it is 36. So what is the best Lewis structure for NH4? NH4 plus. So write down N. And I'm going to take an electron away already because it's plus, and that's what the plus means. Hydrogen is right there. So that's a relatively simple structure.